Hello everyone and welcome. Today we'll be going over Studio 9, which is the final studio of the semester. We've got two parts to this studio. The first part has you working with linked lists to construct a polynomial class, and then the second part has you working with map to do some word counting. So let's go ahead and dive right in. We're going to start with this polynomial class. You can see that we've been given an instance variable, which is a linked list of doubles. These are supposed to represent our coefficients. In fact, this is kind of a bad variable name for this. You might want to even rename that something a little bit more descriptive so that you know what that is. But regardless, this is going to hold our coefficients, and hopefully you looked at the example on the website. We are going to represent the coefficients in a particular way. If we don't have a particular term, then we're going to represent that with a coefficient of 0, and then otherwise we're going to assume that they're all stored in order. So the first term in our list is going to have the largest exponent, and the last term in our list will have the smallest exponent, and all the terms in between will follow suit. So that's kind of the idea behind this polynomial. Let's start with the constructor. Remember, the role of the constructor is to initialize all of the instance variables, make sure they're set up properly. So we only have the one, which is a linked list. We do have some work to do here, though, which is to initialize this linked list. This linked list is an object, so it must be constructed and initialized. We want to have an empty linked list. So in order to do that, we'll call the constructor the linked list constructor. We see that new keyword. That's our key to know that we are, in fact, calling the constructor. Oops, linked. I did not spell that right, did I? It's a little early in the morning. I haven't had a lot of coffee yet. All right. And then as far as our constructor goes, that's really about it. That's all that we are obligated to do. After the constructor is run, we will have a very simple polynomial that has no terms in it. So we're going to scroll down here to the add term next. And so we want to, every time a term comes in, that's we're accepting a new coefficient, right? We want to add that to our list, and so our list of coefficients, we're going to assume that they are going to get added in the order of the exponents that they represent. So we'll just go ahead and add this to the end of the list every single time. That means the first value that gets added will have the largest exponent. The second value that gets added to our polynomial will have the exponent one smaller than that, and so on and so forth. That's the way that this is intended to be used. Now, we can't really test a whole lot of our code yet. We've written a little bit of stuff, but we can't really test a whole lot just yet. Although after this next one we might be able to. We're going to try to create a string that represents this polynomial. So we need to print out every single coefficient. We're going to assume x is our variable, and then we need to print out the exponent as well. So to print out the, we're going to start by by creating a string variable to hold our result. And then we'll just add pieces of this. We'll add one term at a time to this result. So we're going to go through, I like doing perhaps a for each loop would work well here. So for each term in my list of coefficients, I want to tack on a new term. So what is that term going to be? It's going to be the coefficient plus x followed by a caret, and now we need to insert the exponent, which is going to be computed. So I might have made a mistake here, actually. The exponent, well, there's a couple ways we could do this. The exponent is going to start out as, here's one way we can do this. The exponent for the first term, for the very first term, is based on the length of the list. So if I have, 10 terms in my polynomial, I know that the exponent of the very first term is going to be 9, because the exponent of the tail end term, the constant, is going to be 0. And so counting all the way up, if I have 10 items, the exponent of the first one would be 9. So the first exponent that we start off with is going to be the size of our list minus 1, and then it's just going to go down by 1 from there. So if I wanted to, I could do something like this, exponent minus minus. We also, I suppose, want to tack an addition sign on out here so that it strings the terms together. Let's try this now and see. Oops, that's the last studio. That's not this studio. For starters, I have an error. What is it upset about? Oh, I changed the name of this. Yeah, well, I should change it to... that was maybe not the smartest thing for me to do, to change the name of the instance variable right out of the gate, but I did it. It happened, so we're gonna deal with it. Now I can try to run this polynomial test and see if I can examine some of the polynomials that get printed out. So here's P2, 7x cubed plus 5x squared minus, so it's plus negative 2x to the first power plus 5x to the 0. Oh, okay. So here you can see that when we get to the final exponent, we have a little bit of a problem. I don't need this plus sign. I don't even actually need this x term, although it's not really hurting anything. One way we can tackle that is to use a little if statement in here. So if the exponent is greater than 0, then we know we're going to do things this way. Otherwise, we're going to do things a little bit differently. We'll just tack on, d plus... Actually, it would just be d, right? It would just be the constant. We don't need the term. We don't need the plus sign. We don't need any of that stuff. So if the exponent is 0, all we need is the coefficient. So this is good enough for us. Let's try this again and see if that makes our strings look a little bit nicer. Here we go. P2 is 7x cubed, 5x squared, plus negative... There we go. Plus 5. Looks good. Looks good to me. All right. Now let's move on to do some actual work with our polynomial. The first thing that we're going to do is write a method to evaluate the polynomial. So we're going to plug in a value for x, and we then need to substitute this value in for x in each term of our polynomial and compute the result. So it's actually not going to look too much different than what we did this time. In fact, I might start out with a similar situation with my exponent, starting it at the at its first value and counting down as I go. Let's go ahead and get that started up. I'm going to make a result. Start that as 0, right? And we'll just add one term at a time. I'm going to make my exponent start out at the size minus 1, just like last time, since that's our first coefficient. And then I'll go ahead and use a for each loop again. I'm in a big for each loop mood today. I like for each loops a lot, personally. So then for each of these, we need to do, so here's our value for x. D is going to be our coefficient, and then here's our exponent. So we just need to do a little bit of math. Result plus equals D, which is our coefficient, times math.pow, that's how we're going to do our exponent, of x to the exponent. There we go. Don't forget to decrease the exponent by 1 so that the next time through the loop it'll have the proper value. And then finally down here at the bottom we can simply return our result. I believe that would do it, but let's go ahead and run our unit tests here and see. Test eval, there's 2 of them actually. One with some simple tests and one with some more complicated tests. And actually, if you haven't, I would suggest you take a look at the test because some of these are very easy to figure out. This is saying that, if I plug in 2 to this polynomial, then I should get an answer of 77. That's what this test is saying. If I plug in 100 to this polynomial, I should get an answer of 0, right? That's what that's saying. But so far, so good. Our next and final task for this part of the studio is to compute the derivative. We're going to use the power rule to do this. And notice that the return type is a polynomial. So we actually need to create a new polynomial that represents the derivative and add the derivative terms to that polynomial one at a time. So let's go ahead and start that up. I'll call the constructor. This is going to create a new polynomial for me, right? But then otherwise, I'm actually going to, scroll up here and kind of start the same process. I'm going to set my exponent because I'm going to need that to do the power rule. I'm going to write a for each loop to go through here and visit each one of my coefficients. And then the next coefficient is just going to be the current exponent multiplied by the current coefficient. So I'm going to say exponent times d. That's our next term. And so we're just going to add that to our derivative using the add term method. finally, once we've done that for all of them, we're just going to go ahead and return our derivative. Okay, let's run our unit tests and see if this satisfies our derivative. And unfortunately, we have a problem. Let's see. We can see that, where did I go off the, oh, I see one thing that I forgot to do. I need to subtract 1 from my exponent. So let's run the tests again now that I've fixed that little mistake and see if that helps at all. So it's saying that P2's derivative is 21x cubed, 10x squared, and then negative 2x plus 0. We've got too many terms, right? You see how we've got too many terms? This plus 0 is having the effect of shifting all of these terms down. It should actually only be 3 terms. So here's P2. It should be 21x squared, right? 21x squared. So what happened? I got 1 too many terms. If the exponent is 0 or greater than 0, then I need to do the power rule, right? But if the exponent is 0 or less, then I actually don't wish to add that term. The power rule doesn't apply. That term's just going to fall out. So let's just try that again. Ha! There we go. Once we fix that mistake of adding on the extra term, we've successfully computed the derivative, and our polynomial test passes. All right. That's going to wrap it up for the first part, although the one final thing that I want to take note is that we did provide you an equals method down here along with the description. Hopefully you took a look at that. The one thing that I want to make clear about the equals method is that I don't really write this stuff, right? I don't write an equals method. I usually let Eclipse do it for me. The big choice that you have when it comes to writing the equals method is which of the instance variables do you want to compare. It might be possible that necessary for you to compare all of the instance variables to determine equality. That's the case here, and that's okay. But in other situations, it may not be necessary for all of the instance variables to be involved in determining equality. It's your choice as the programmer to decide what instance variables should be used to determine equality or not. And so, yeah. All right, let's move on to part 2, which is the word count method. So for this method, you're going to be given a list of strings. You're going to be given a list of strings, and we wish to create a map where the key for that map is a word, and the value is how many times that word appears in this list. So for the example, to be or not to be, you can see here that the word to shows up twice. So I would expect to see a value of 2 associated with the key of 2. That's a little confusing. The word be also shows up twice, so same story, right? The other words only show up once, so they would have a value of 1. Okay? So let's go ahead and start this out. We need to examine every word that's in this list. So I'm going to use a for each loop again. I really like for each loops a lot. And there's no reason not to use one here. Now, every time I examine a word, we have to be careful with this map because there are 2 situations that can happen. Either I've seen this word before, meaning that it's already in this map, or I haven't seen this word before, meaning that it's not already in the map. So what we need to do depends on that situation, whether the word is already in the map or whether it's not already in the map. Before we do that, though, I suppose I should actually create a map. So let's go ahead and create a hash map to store our results. We've told you what the types for the keys and values should be. It should be strings for the keys. Those are the words. Integers for the values. New hash map with the brackets and the parentheses. So here, this will create our new hash map for us. We want to look up and see if this word is already in the map. If it's already in the map, that means that there's a number, there's a value in the map associated with it already. So we just need to get that number out and add 1 to it, right? So first off, let's see if we can figure out if the word's already in the map. We need to have some way of determining that. Let's take a look at the API. You can look this up on Google. That's what I do a lot of times. Or you can also just type in a dot after the variable name, and it'll show you what you can do. And what I would like you to remember from class is that if I get something from a map and it is not in the map, then the map will return null. Okay? So if I look up the word in the map and the map says null, that means that I have not seen this word before. This is a brand new word that we have not yet seen before. The fact that we're seeing this word now means that we have seen that word exactly one time. So all we need to do is reflect that fact in our map. So I'll go ahead and say word count dot put. That's how I make a new entry, right, into a map. And I'll say that I have seen this word one time. This is the first time that I've seen the word, right? So I will reflect that fact by putting the number 1 into the map associated with this word. If it's already in the map, that means there's a number in there. There's already a value associated with that key. So, but we don't know what that is. So let's pull that out first. So pull out whatever the current number of times is that we've seen. And then we have to add 1 to that value and put it back into the map. So I'm going to say word count dot put, and then I'm going to say count plus 1 here. Remember that I cannot have the same key show up more than one time. So if I put something into the map and the key already exists, it has the effect of overwriting the value. So it just replaces whatever value was in the map with whatever this new value is. So I'm going to take whatever value was in there and I'm going to replace it with a value that's 1 bigger, because I have now seen this word 1 additional time. I believe that'll do it. We can go ahead and say return word count down here and then see if this satisfies our tests. Let's go ahead and run the unit tests. There we go. That's going to do it. So this is going to satisfy our initial task, but then let's come down here for a second. Here's the exact example that we saw from before. I want to actually verify that this is working properly by iterating through the map that has been generated and printing out all of the contents. So you could actually do this a little bit differently if you wanted to. You could actually print out the map directly, and I can show you what that looks like if we run this application. So here you can see, here's the contents of the map, right? Not B or 2, and you can see 2 has 2, B has 2, the other ones have only 1 value associated with it. But what if you really wanted to iterate through the map and examine all of the contents 1 key value pair at a time? That's an important thing to know how to do. The part that's tricky about it is that there's no order to maps. There is no order to maps. So you can't use an index. You cannot use a for int I equals 0. You can't use a loop like this. I've been leaning on the for each loops heavily today, in large part because to iterate through a map, you have to use a for each loop. It is not optional. So in particular, we're going to iterate through the key set. So I'll go ahead and make a for each loop. The keys are strings, so I'm going to iterate through all of the keys. So I'm going to say for string key in, and then I want to get the set of keys from the map. So I'll do that by saying key set, by using this key set method. Now that I have the key, I can, of course, print it out if I want to. Key, or rather, I probably just would rather do something like this, and then colon, and then I'm going to retrieve the value from the map using the get method. So I'll say words.get, and then plug in that key. That should get me the value associated with it. So now if we run this code, we can kind of see the difference between, printing out the entire map or iterating through the map one at a time. Here you can see that I've formatted these a little bit more nicely, and it works just fine. All right. That's going to wrap up the studio. This is the last studio of the semester, so this is the last studio review video of the semester. We're almost there. I'll see you all in class.